All right, so now we're ready for the history. Okay, so we're going to talk about the history. This is really, I think you'll find this pretty interesting. I'm only going to do history today, but pretty nice history. Okay, so the big names in machine learning are Rummel. Well, those papers certainly that I provided. Take a look at those names. There's none of this would be possible without an optimization technique, backpropagation. That's the famous 1986 paper by Rummelhart, Hinton, and Williams. Do any of those names sound familiar? None of them? In particular, Hinton, that's Geoffrey Hinton, is basically the grandfather of deep learning. So it's like the guru. Okay. Yeah, but that paper is pretty important. That's the algorithm of gradient descent, which, like I said, without it, unless we have a quantum computer that randomly selects the weights, we would not be able to solve a neural net. All right, it's very interesting how they do it. Okay. All right, so the history. I'll do like a timeline. Okay. And so we will start. A little timeline here. All right, so obviously everything builds on top of everything, right? So we've seen already what was that theorem that we saw initially, the triangle one? Beginning of the semester, we saw a formula. Well, starts with a P. Huh? Yeah, right? When was that dated from? I don't know, but that's math way back, right? Yeah, or the Greeks, right? So those are pretty old things. So what I'm trying to say is, obviously, a lot of math came before what I'm discussing, right? Because we use that, right? Pythagoras, right? Pythagorean, theorem. What is it in Egypt? Wow, yeah. So so that we used to calculate what? We used it in the in calculations, right? In the triangles, and then we have the Euclidean distance, right? We also Euclid, I guess, right? All of those things can be used in machine learning, right? So there's quite a bit of background in math, obviously. So I should say before the, since the beginning of civilization. But this discussion will start in the 1940s, okay? So it's more of a related to just neural nets in general and not just KNN and all the equations. So it kind of starts in two places, right? It starts at Bell Labs. So do you guys know where Bell Labs is? New Jersey, right? It used to be in New York and then New Jersey. Bell Labs. So you guys have heard of Bell Labs, I assume. You have not heard of Bell Labs. You know that everything was invented at Bell Labs, right? Some people will disagree with that, but a lot of things. One very important thing that was definite, that's a joke, but one very important thing that was invented at Bell Labs is the transistor. Transistors are what make computers possible, right? And so that definitely is a very important thing because we would not have computers without the transistor. So yeah, Bell Labs is AT&T, I think. It used to be called Bell Labs. But again, going back to neural nets, two important people are Rosenblatt. So you saw, Rosenblatt here. Rosenblatt. So this is the person that created the perceptron, okay, which is the algorithm that we're going to discuss, this week. The perceptron. It's kind of like the first neural network. Yes. All right. So that was around the 1940s. So I think they still had now, because the transistor was just then being invented, right? Which is the little chip. They were using what? Like the vacuum tubes, I think, and relays, and still they were kind of building computers that way. Do you guys see that? But around this time, obviously, came the transistor. I forget the name of the person that invented that. You can look it up. Alongside there was also a gentleman named Claude Shannon. Have you guys heard of Claude Shannon? Basically, no, is the father of information theory, right? So actually your major, IT, which is based on information, that's kind of Claude Shannon. So Claude Shannon did a lot of things, invented information theory, obviously, which is somebody told him to coin a metric called the bit. Do we use a metric called a bit? Yes, right? And that's where it came from in the 1940s. Claude Shannon is like an eccentric guy, worked at Bell Labs also. And very funny, he would ride a what do you call it? The ones that only have one wheel, the bicycle. What is that called? Unicycle. So at Bell Labs, he would ride a unicycle in the halls of it. That's how eccentric he was. Okay, they just kept him in there, gave him an office, and just told him to do whatever he wanted. I'm not kidding. And while he was not doing anything, he invented information theory for AT&T. All right, so, Bell Labs. Anyway, so very interesting guy, invented that. Then he got bored with information theory and he switched to cryptography. So he kind of invented cryptography also. He's the first one to define what makes a secure cipher. If you guys take 350, which is the crypto class, we'll talk about Claude Shannon. All right, and then he got bored with that once he had invented everything. And he decided that he was interested in AI. So he invented the very first, you can look this up, it's in a museum, the very first like AI game, I guess, which was a robot mouse, which was nothing more than a magnet. He built a labyrinth and the robot had to figure out how to traverse the labyrinth to find the cheese. The thing is, you can get lost in a labyrinth. So the goal was for it to just try it, learn, and eventually just get to the cheese without trial and error. Does that make sense? So that's Claude Shannon. So it's called a robot mouse maze. Okay. So maze. So robot maze. Okay. All right, so this is in a lab somewhere, you can look it up. All right, so that's kind of where they were in the 1940s with, like I said, Rosenblatt. Somewhere along there, like in the 50s, came Adeline. So it's an algorithm supposed to be a little bit more advanced. Then really, between all the excitement of the perceptron, don't forget, that's the start, by Rosenblatt, and maybe around the 1980s, we had what is probably called the first winter of AI. And what that means is there was a period of like deadness. And this was thanks to a gentleman called Marvin Minsky and a paper he and another person wrote, which was misunderstood. And basically, without getting into too many of the details, what Minsky did is he said that neural nets in a specific configuration could not solve a lot of problems. But then somewhere in the paper, there's a comment that says, oh, but if it's a multi-layer perceptron, then there's no problem. But somehow, I'm not kidding. I tell you this because although it's not relevant to stochastic gradient descent, I think it's relevant for you to see how AI sometimes is a lot of perception. Sometimes there's a lot of hype. Sometimes there's a lot of realism. The algorithms work fine, but people lost interest because they basically just read the first page of Minsky's paper. And this is a true story. And so a lot of people just didn't continue working on machine learning or neural nets because they felt that it didn't have what they needed, okay? Also, obviously, they had just invented the transistor, so there was very little that they could do, honestly. But this influenced things quite a bit. The next big pickup, I guess, was around this time, as you saw in the what I said around 1986. Backpropagation came out, the paper. It's called, sometimes people call it backprop. That's the algorithm that we're going to learn about a lot in this course, which is the one that allows you to learn the weights efficiently. Okay, very, very interesting. And this was, as I've already stated, Geoffrey Hinton. Geoffrey Hinton was one of those people that he didn't care about what Minsky said or whomever, right? It's just one of those people that have a passion for something and just do it, right? Doesn't care if it's going to work or not. They just wanted to work on neural nets. So he's got in the 70s, I think, like the first Ph.D. in AI. They just made it up for him, right? And that's how intrigued he was. So that's Marvin Minsky. Jeffrey Hinton. He's a professor, still alive, at the University of Toronto, in Toronto, Canada. British fellow, came to the United States. All the funding was in military applications, did not want to work in military applications. Canada offered him, like, do whatever. And so he went over there to the University of Toronto. Basically, all of his students that went into his classes, have had a lot of success. All right, so that's Jeffrey Hinton in 1986. So this takes us to around 2000. But what was happening here is computing power was improving, right? You guys probably remember some of these computers, maybe a little bit before your time, but you know that there were computers around this time, right? In 86, in the 80s, there were computers. There was the internet already. So there was a lot of excitement there. But because of kind of this Minsky paper, still, people thought neural nets are not great. And a lot of people did not work on neural nets, except for Minsky. I keep saying Minsky, except for Hinton. So Hinton was the kind of person that would go to conferences. And at conferences, you usually have these dinners, and he would just get like the worst table. Oh, those are the neural networks guys. We're going to put them in the back of the con. This is true story. I'm not kidding. All right. But they kept working. They obviously invented or developed stochastic gradient descent, that paper from 1986. And we're leading up to something, right? So there was this darkness. People just wanted to work, the KNN, right? There's other machine learning algorithms. People were doing machine learning, but they were just not doing neural nets, right? Because of all this, like, it's not clear how they work. They don't work. What's going on? But anyway, my point is, Hinton is a good example for you guys of persistence. And this is me just being like, if you have a passion, follow it. Even if people hate, laugh at you, if you love it, eventually you could be the next Jeffrey Hinton. Oh, the story about Google is very, very interesting. Jeffrey Hinton is a professor at Toronto, right? When he became all famous, Google went to the University of Toronto, offered him a ton of money, moved to California. Google, we'll give you whatever you want. He said, no, I like Toronto, Canada. I'm happy here. You know what Google did? They built the office in Toronto. They brought Google. I'm not kidding. The second Silicon Valley in North America is in Toronto, after California. Why? Jeffrey Hinton. This happened. This is a story. They tried to recruit him, but he just didn't want to go. He'd been a professor at Toronto. Toronto's pretty, I've heard. So he just didn't want to move. They built it around him. I think they built a building around him. They gave stuff to the university, and then eventually he kind of just accepted. Okay, and that's it. That's pretty much how it happened. So this is a very true story, but we got really ahead there. So what is really the event that changed everything? So you can see that Jeffrey Hinton was working hard. Other people, obviously. So the paper. He didn't write it alone, right? So there was Rumelhart, Williams, there were a lot of people working on it. And also people would just stumble to the University of Toronto. Hey, there's a neural networks class. Would go in there and it's with Jeffrey Hinton, right? So they're the only ones in the world doing this, because other universities are, nah, that's not, we're not going to do that. You see what I'm saying? This is a great example of persistence. But anyway, so they were building all the algorithms, all the techniques with the computers that we have today, right? They wanted to build deep learning algorithms, but computers couldn't really. So now we're getting to the point where all the framework and all the algorithms are kind of built, but the computing power was still not there. But something happened. There's an event that's like changed everything. And that happened around 2007. In 2007, NVIDIA came out with their, believe it or not, with their GPUs. The GPUs that finally made this possible, made like actual deep learning, you know, a GPU with however many GPU processors it has. And that really, that in 2007, we get that's really a thing that is really important in history. Why did NVIDIA create these GPUs? Not for machine learning. They built them for video games, right? That's what these things were for. Do you get how GPUs for video games can also be used for machine learning? Do you guys get how that works? All right, so if you think of a computer game, right? First person shooter or whatever. Imagine me, I'm a mesh, right? In that 3D space, correct? In linear algebra, we know that if we want to move something, stretch and rotate something in a vector space, what do? We multiply it times something else. It's a classic like thing. So you have a matrix, multiply it times a vector. That's a stretching and rotation of it. That's it. And so in video games, let's say I'm a mesh like this with the gun, right? I'm not going to move, but I'm not going to like, like a game with the arms, or what I mean is it's not going to move the arms. I just want to move to Gang Rock, right? Where you are. I want to go over there in that vector space. I'm a mesh, which is basically I'm a matrix in that space. Find the vector that when you multiply me with, it moves it. Because as I said, that's what linear algebra does. Matrix and vector multiplications, by definition, they are stretching and rotating operations. That means it moves and, that kind of thing. You just have to find the right values to do that. Well, in machine learning, as you learn in NumPy, right, when you did your NumPy things, what were you doing? Matrix and vector multiplications, yes? Were you not doing the exact same thing? Except that in video games, it's like 3D kind of a thing, and machine learning is higher dimensional space, but GPUs are made for that. There's no limitation. And so anyway, is that clear for you guys? Do you kind of get what I mean? Yeah. All right. So GPU basically, if you get confused, the mesh is, or the rendering is the matrix, the mesh, and then you want to move it to another location, multiply times a vector, boom. It physically moved. Why do you want to do that in a GPU? If you do it in a CPU, what's going to happen? You have to multiply like this, right? You have to go with, multiply the top and go down. So when it renders in the game, you see this shape, right? What do you want? You want the whole thing to move at the same time. You do the multiplication in parallel. Do you agree? And now you don't have, what is this called in a video game? Like a jittery effect, or I don't know what you call it. Lag, maybe lag. You don't want to see that lag. They were fighting that lag in video games, and they built the hardware. So obviously this hardware does that parallel operation. Just think of it. It sends the feet at the same time as the head to where it needs to go. That's what they were getting at. It didn't take very long for these guys at the University of Toronto to see, hey, wait a minute. That's the exact operation that we're performing, matrix and vector operations. NVIDIA made available something called CUDA around 2007 as well. This is the C++ library that allows you to control the GPU. Like literally you write the code in C++ CUDA, and you get the GPU to do things. It's actually very hard to code in this style. Okay, it requires serious parallel understanding. Okay, so in 2000, but they were up to the challenge at the University of Toronto. So the next time that we kind of hear about them is in 2012. So about 5 years took place between these GPUs. Probably they made their way into the University of Toronto, Jeffrey Hinton, their teams, a few other teams around the world. And what happened in 2012? This is the moment that everybody became aware of deep neural networks. Okay. What happened in 2012? What do you think happened? Oh, there's a movie about that. I don't think that's related. What happened in 2012 is there was a competition. There was always a competition, not just in 2012. There was a competition yearly, which basically they had something called ImageNet. And ImageNet was a data set of 1.4 million images or so, right? And basically what was going to happen there is they had, I don't know, like 100 classes, bird, bus, car, cat, dog, something like that. So every year they have this data set, this challenge, they make the training set available, but they keep a test set that they don't share with anyone. And then they say, okay, build your machine learning tool, enter the competition. Let's see who gets the highest score, right? Do you see why the performance metrics are so important, right? When I make the joke sometimes, let's see who does better in this class, right? By measuring performance. You guys see that? Well, in 2012, one of the students, I believe, of Jeffrey Hinton built something called AlexNet. AlexNet entered into this competition and won. And it didn't win by like 1%, right? For something to be significant like this, it had to be by a high percent. So I think it was like 15 or 20%. We're talking about everyone was around probably, let's say 70% on this task. Just classifying, this is an easy thing today, by the way. But back then in 2012, not that long ago, 10 years ago, it was pretty hard. So they had to, because it was like 90 classes, and they achieve, I believe, around 85% accuracy over everyone else. The companies that were already in this space, Google, Facebook, were shocked, right? That because they have an interest for ads and things like that, and having pretty good, they want to give you an ad that leads to money, things like that, right? So AlexNet did, and this is what changed everything. So they asked, obviously, what is AlexNet? So it turns out AlexNet was a deep neural network. Had multiple layers, it had stuff. Now, I should probably mention something that in the 80s, there was a guy named Jean LeCun, because he might see this video and then hate me forever. So Jean LeCun is the director of AI at Meta. He is also a person considered very important in machine learning. He built MNIST. You guys have used MNIST, right? MNIST was built for the post office. And it basically, how letters are written, the zip code is written by hand, and they wanted to sort it mechanically, right? Makes sense. So if you put a camera, look at the zip code, boom, you send it in one direction or the other. His whole task was to do, that character recognition, like MNIST. You guys see that? Handwritten digits, the 10 numbers, 10 digits, yeah? That make up zip codes. And Jean LeCun, I believe, is also the father of CNNs, I want to say. I believe he invented them, or at least he perfected. Sometimes it's not that they fully invented something, but they perfected it, right? Well, he had built the CNN. What is a CNN? It's a deep neural network, but a higher level, beyond what we're going to study in this class. And I believe AlexNet, I bring it up because I believe AlexNet is a deep neural network that used CNNs. Okay, you'll have to, you can research that on your own. I don't remember the specifics, but I do know it was a deep neural network, probably CNN. They had the GPUs from 2007. This is the moment where this stuff really like became a thing. Okay. This is where the general public started to find out about neural nets. I'll be honest, around 2014, I was still probably a little bit clueless about deep neural network, right? So I wasn't really in the loop, right? And that's really that happened to a lot of people. Okay. So the framework that you guys are using, Keras, is based on TensorFlow. Believe it or not, that was not available until 2015. That means before that, none of you would have been able to do machine learning or deep learning. You really can't without that. I mean, it makes it super easy. So you definitely want to appreciate it. PyTorch came a little later when Facebook just didn't want to use Google products. So they developed their own. And then Keras, I'm not exactly sure, but it came, like, I think I told you this. It was just somebody didn't want to use TensorFlow 1, so they built like a wrapper around TensorFlow 1, and then everybody liked it so much because it made life easier that in TensorFlow 2, it is now just like part of the thing. Do you guys get it? All right. So another important thing is that there's deep learning, which is kind of what we're going to spend a lot of time on here. And then there's even more complex architectures than standard deep learning architectures. That is probably outside of the scope of this class, but there's a few algorithms there. I've mentioned one, CNNs. They're like, just think of it. There's deep learning, and then CNNs just have more stuff on top of deep learning, right? And then, so that's kind of there. And then we are basically, what is it this year? So 2023. So all the rage is Chat GPT, right? That's all the rage. All right. And the algorithm that made this possible was invented. Guess when it was invented? Let's see if you guys can tell me when you think the actual algorithm for Chat GPT. When do you think it was invented? A long time ago, recent? Huh? 2017. This is the classic seminal paper, Transformers is All You Need, by Viswani, I think. This is the thing that made this thing possible. Without this, we would not have this. Transformers solved a lot of problems. I mean, the paper is literally called Transformers is All You Need. It's implying everything else is not necessary. Jean LeCun would not like that because he invented CNNs. All right, but anyway, that's kind of the history, okay, that I wanted to give you guys. And I like it. I mean, I really enjoy. I believe it's important to understand the context of all of this is let me just finish. Pretty recent, and who knows what the future will be. Could we have another winter? We could. But we haven't had one. I mean, things are very interesting now, and so think about the thing that this algorithm changed a lot. So there may be other algorithms that will come that will change even more. Yeah.
At what point was people been afraid of AI?
When did that start? When they, I think, yeah, that's actually a really good question. Well, I think, yeah, the Terminator is like, I think, yeah, everyone has always had this idea of like the Terminator, but realistically, I think with the language models is when people started to actually really be worried about, because all these are transformers, they all have bias. They all have bias. Why do they have bias? Because machine learning algorithms are biasing machines. That's literally what they learn. Do you know what I mean? They learn whatever the majority class is. Right? You give it 100 examples of one thing and 10 examples of the other thing, it just learns that 100 thing is more abundant, and that's the thing that it's always gonna do. That's biasing, right? It's not fair, because that's inherent in how they are. So there's all this about what they're gonna do. That this is why Bing and all of them are really nervous about releasing like Google. Supposedly they had a thing called Lambda before, and they did not want to release it because Google was in a position where it's more problematic for them if this thing starts to do unexpected things, right? Whereas ChatGPT was developed by OpenAI, kind of a small, we're not doing anything company that, by the way, belongs to Microsoft. Microsoft, because they've been trying for so long to get Bing to work without success, they saw all the hype of ChatGPT. They were very smart, actually. They let OpenAI do all this hype. They were watching it and watching it and watching it. And eventually they saw, hey, we can use this as marketing, basically. And they just said, we're going to incorporate it into Bing. They own OpenAI. They own 49% of it. So OpenAI was, do you know who gave the initial funding for OpenAI? You'll laugh.
Elon.
Elon Musk. Elon Musk gave the initial funding. So again, I think he's an alien probably, or from the future. Because again, Elon Musk doing something, right? So, huh?
Because when we first invested in, they had created a video game AI that could be beat. And
Yeah, AlphaGo, you mean probably? Yeah. But that at that point, AlphaGo was still research. AlphaGo was still just some amazing research. Yeah. Yeah. Yeah, no, yeah. He says, so he says, and yet he's building stuff at Tesla that he's not telling you about. That may be it. He may be an AI from the future. Maybe. But it's funny that he gave the funds for OpenAI to be an open source, not a company thing. But that's why he doesn't have any money in it. And he probably is very sad about that now. And he gave, but then he, I guess, gave him permission or whatever to become semi-private. And then Microsoft bought like an initial 10% of it. And then they had like AlphaGo, but ChatGPT is different. And recently, Microsoft just gave him $10 billion, I think, for a 49% stake in OpenAI. And because of all the hype of ChatGPT, you guys will be the judge of whether ChatGPT is useful. I've heard it's really good at coding, and that's really interesting. And so, we already like. I'm sure all of you, when you code, the first thing you do is you Google how to do it, right? And then copy that code. Well, that's kind of what ChatGPT does, is you just write the text and it gives you the code. And so, yeah. So they've made it part of Bing now, basically, and they're going with that. But that's kind of the story of all of this. Any questions?